Question 1. Which side of the triangle below is the hypotenuse? MN, NP, PM, or MP? The longest side is known as the hypotenuse, and we can name that for the two letters that are each end of it. So MN is the hypotenuse of this right angle triangle. Question 2. Which is the correct Pythagoras theorem statement for the triangle below? Is it E squared equals D squared minus C squared? D squared equals C squared plus E squared? E squared equals C squared plus D squared? Or C squared equals D squared plus E squared? Pythagoras says hypotenuse squared equals one shorter side squared plus another shorter side squared. Our hypotenuse here is the E, the longest side, and so it'll be either A or C there. But the proper Pythagoras rule here is E squared equals C squared plus D squared. We wouldn't have any minuses in there. The minus comes about if we're trying to find one of the shorter sides, which we'll see in another question soon. Question 3. Which is the correct Pythagoras theorem statement for the triangle below? We have a triangle with H, K and J. Is it KH squared equals JK squared plus HJ squared? Is it JK equals HK plus HJ? HJ squared equals HK squared minus JK squared? Or JK squared equals HK squared plus HJ squared? Okay, hypotenuse squared equals 1, that's shorter side squared plus another shorter side squared. Now the hypotenuse here could be called JK because that's the longest side. So we notice that B and D have JK as the first item there. One of them's squaring everything and one of them's not squaring everything. So I'm liking the look of D there. JK squared, which is the hypotenuse, equals HK squared, which is one of the shorter sides, and HJ squared, which is the other shorter side. So it's just a matter of getting the right combinations there that match Pythagoras' theorem. Question 4. Find the length of the hypotenuse below. We've got sides of 6 and 8. And Y is on the other side. Okay, Mr. Pythagoras says that a hypotenuse squared equals one shorter side squared plus another shorter side squared. Our hypotenuse is the longest side, so that's our Y. So we'll start with that. Y squared equals one of the shorter sides, 6 squared, plus the other shorter side squared. So that's our Pythagoras theorem statement, we'd call it. And we'll just simplify that. Y squared equals 6 squared, which is 36, plus 8 squared, which is 64. 36 plus 64, I'm here to tell you, is 100. So we've got y squared equals 100. We need y on its own though, so let's get rid of the squared. The opposite of squaring something is square rooting it. So we'll square root both sides. If we square root the left-hand side, it'll cancel out the square, leaving us with just the y. And we'll square root the right-hand side. Square root of 100 is 10. So the length of the hypotenuse there is 10 in the end. Question 5. Find the length of the hypotenuse below. Give your answer correct to 1 decimal place this time. Pythagoras says hypotenuse squared equals one shorter side squared plus another shorter side squared. So the hypotenuse here is the longest side, which is our C. We'll start with that. So C squared equals 7 squared plus 9 squared. Doesn't really matter about the order of those second two numbers there because they're just getting added and order doesn't matter when we're adding. So let's start simplifying that. C squared equals 7 squared is 49. 9 nines are 81. And we'll add those two together and get C squared equals 130. To work backwards there, we'll square root both sides to get C on its own. Square root of 130, we look back at the question and they want a 1 decimal place answer, so we'll run that through our calculator and get 11.4, rounding it off carefully. Question 6. Find the length of the hypotenuse below, giving your answer correct to 2 decimal places this time. We have a triangle with K, 13 and 8 in it. There's your hypotenuse situation. Your hypotenuse is K in this situation, so K squared going to equal 8 squared plus 13 squared. 8 squared is 64, 13 squared is 169. Let's add those two together on the right hand side and make things a little simpler for us. K squared's 233. We'll square root both sides to get K on its own. And on the right hand side, square root of 233. And we run that through our calculator and round it to 2 decimal places. We should get K equals 15.26. So we're just running this through Pythagoras procedures. Question 7. Find the length of the hypotenuse below. We want to leave your answer in exact form this time. Alrighty, Pythagoras says that, so our hypotenuse is n, so n squared equals 7 squared plus 9 squared. N squared equals 49 plus 81. N squared equals 130. We'll square root both sides to get n equals square root of 130. Now interestingly, we leave it as a square root. That's what is needed when they ask for exact form. Now a previous question you may have seen recently, even in this same set, would have gone on to run that through your calculator and pressed 130 square root or square root of 130 and got an answer and rounded it off, because that's what that question needed. With the same numbers here, we're leaving it as a square root to make the point when they ask for exact form, we don't square root on our calculator, we leave our final answer as the square root of some number or other. They don't ask this all the time, but watch out for it. Question 8. Find the value of the shorter side, G, in the diagram below. Leave your answer as a whole number. Okay, we've got the letter squared. Now this is a shorter side we're finding here. So this is the Pythagoras version that I like to use for finding a shorter side. We start with the letter that we're trying to find, squared, equals the bigger of the two sides, squared, minus the smaller of the two sides, squared. So we've just rearranged Pythagoras a little bit, and we just have to remember that when we're finding a shorter side, there's a minus involved. Okay, so we've got G squared, the letter squared, equals the bigger side squared. So the bigger out of those two is 26 squared, minus this time 24 squared. So it's a little bit different, but it saves us rearranging the normal Pythagoras theorem set out. So we can just go straight to a shortcut way for finding shorter sides. So G squared equals 26 squared, I'm here to tell you, is 676. Minus 24 squared, which is 576. So we get G squared actually equaling 100. And as we do normally with Pythagoras, we'll square root both sides to go from a squared to just the normal G. Square root of 100 is 10. Alrighty, so that's finding a shorter side. Remember, there's a minus involved in the Pythagoras setup there. That's how I like to do them anyway, there's variations. Question 9. Find the value of the shorter side v below. Give your answer correct to 1 decimal place. For finding a shorter side, I like to use this setup. We'll have the letter squared equaling the bigger side squared minus the smaller side squared. So the letter is v, so we'll have v squared equals the bigger side 16.4 squared minus the smaller side 7.6 squared. And it's just a matter of processing that. V squared equals 268.96 minus 57.76. V squared equals 211.2, and we'll square root both sides to get a final answer there. V equals 14.5 if we've rounded that off to 1 decimal place like the question asked us to do. And question 10. Find the value of the shorter side P below. Give your answer this time correct to 2 decimal places. The letter side squared equals the bigger side squared minus the smaller side squared, because we're finding one of the shorter sides here. So the letter is P, so we'll go P squared equals the bigger side squared, which is 33.74 squared, minus 22.6 squared. When we run the numbers on that, we get that big number minus that big number. Simplifying that, we get P squared equals 627 and change. Square root both sides to get P on its own, and run that through your calculator, rounding carefully to 2 decimal places like we're required to do in this question. Hope you're getting the hang of those. Enjoy.